We present DreamSteerer, enhancing source image condition editability using personalized diffusion models. Existing works have shown that text-to-image diffusion models can achieve high-quality zero-shot image editing with simple text prompts, even when they are not specifically trained for this task. However, the expressiveness of language is limited. Imagine the target edit is to change a dog in astronaut suit into your own pet dog. How would you describe your pet dog? It remains ambiguous with only language. In this work, we focus on bridging such gap. We first conclude the desiderata for personalized editing. Firstly, the overall structure of the edited image should align with the source image. Secondly, the edited part should capture the appearance and content of the personal subject. Finally, the instruction irrelevant part should be preserved as much as possible. One preliminary solution for personalized editing is to directly perform zero-shot image editing with existing personalization models. However, we observe that this preliminary solution often shows unsatisfactory performance with poor structural alignment with the source image and severe artifacts. We conclude several reasons that make personalized editing difficult. Firstly, the limited data scope for few-shot learning makes the model prone to collapse to certain attributes. Moreover, there exists a stricter demand from generation to editing that may require extrapolation on attributes. To solve this problem, our main idea is, by looking at the source image, without further supervision, can we make the personalized model more editable? Our main strategy is EDSD, Editability Driven Score Distillation, which fine-tune a personalized diffusion model for better editability on a given source image. The key insight is that a good editing step should lead to improved denoising performance. For a given source image, the source diffusion model has better denoising capability than the personalized one, as it is less biased to the reference images. We parameterize a single editing step on the noisy latent state of the source image using the personalized model. We then optimize a score distillation objective to encourage the personalized model to deliver effective single-step personalized edits, thereby reducing its denoising performance gap with the source model. However, we observe that although this structural preservation is indeed improved with EDSD, it may cause the personalized model to collapse to a trapping point between the source subject and the target subject. As shown in the example here, both the edited and the generated cats show a hybrid appearance that fall between the source and the target. To avoid the collapsing issue, we are motivated to regularize the training of EDSD. And how should the regularization set look like? In accordance with the two important criteria for personalized editing, it should satisfy both target appearance alignment and source structure alignment. The former is easy to achieve through personalization, whereas the latter is an open problem. The main challenge comes down to how could we guide the sampling process of a personalized model with the source structural information. Existing works have shown that the self-attention features of diffusion models have a strong sense of spatial awareness, which can be used to build accurate semantic correspondence between two objects. Inspired by this, we choose the self-attention feature from the source image to perform as a guidance with the source structure information. Specifically, in the forward diffusion process, we start from the source image and extract its spatial features. In the reverse diffusion process, a structural similarity loss with the source image feature is computed and serve as energy functional guidance for generation. This guided sampling strategy can generate samples fulfilling our expectation for the regularization set, that is to preserve the source image structure and the target concept appearance. Here are more spatial feature guided sampling results. With the regularization of spatial feature guided samples, we can see that the collapsing issue of EDSD can be avoided, with the generation and editing results better preserving the target appearance information. Meanwhile, we observe that the generated images show appearance-irrelevant patterns that are similar to the source image, like the blue color on the cat's neck and the presence of two cats. This effect suggests that our regularized fine-tuning strategy can steer the mode of the personalized model to a place that is more friendly for the source image, which is further validated through the improved editing result. Here are the editing results comparing with the baselines. With around 1 minute of fine-tuning on a single GPU, our work can serve as a plugin that significantly improves the editing performance of the existing personalized baselines. And here are more editing results. Thanks for listening.